This line introduces the input data, a list of numbers, that will be used as input for the unique_labels function. This is the target variable, a fundamental concept in machine learning classification problems representing the class labels associated with data points. Each number represents a different class or category. We'll use this data to explore how the function identifies unique classes. Let's look at the numbers together. This line shows the actual list of numbers, the target variable y. Notice that there are repeated numbers. The unique_labels function will help us identify the distinct classes present without repetition. From the given numbers, we can see that the numbers are 0, 1, 2, and 3. This line indicates the function call using scikit-learn's unique_labels function. From the Sklearn utils multiclass module. This function is used in machine learning to extract the distinct classes present in a given dataset. The input is the previously defined array y, and the output will be a list of unique values in the order in which they first appear. This line prepares you for the result of the function call from line 5. The output array will contain only the unique class labels from the input array y. This is the result of applying the unique_labels function to array y. It's crucial to note that the order of the unique labels is not sorted numerically but preserves the initial order of appearance in the input array. For example, 0 appears before 1, 1 before 2, and 2 before 3. This information is critical when analyzing the results and evaluating the statements in the quiz. This refers to a function within the scikit-learn library in Python. It's designed to find the unique values in a given array, like the unique classes in a machine learning classification problem. Think of it as a tool to quickly identify all the different categories present in your data. This refers to a function within the scikit-learn library in Python. It's designed to find the unique values in a given array, like the unique classes in a machine learning classification problem. Think of it as a tool to quickly identify all the different categories present in your data. This is the input array for the unique_labels function. It's a list representing different class labels, possibly from a machine learning dataset. Notice that some labels, like 0, 1, and 2, appear more than once. This is the input array for the unique_labels function. It's a list representing different class labels, possibly from a machine learning dataset. Notice that some labels, like 0, 1, and 2, appear more than once. This is the function call. We're applying the unique_labels function to the input array y. The result will be a new array containing only the unique values from y. This is the function call. We're applying the unique_labels function to the input array y. The result will be a new array containing only the unique values from y. This is the output after running the unique_labels function. The function has successfully extracted the unique class labels 0, 1, 2, and 3 from the input array y. This is the output after running the unique_labels function. The function has successfully extracted the unique class labels 0, 1, 2, and 3 from the input array y. This statement claims that the output of unique_labels y is a NumPy array, a specialized data structure in Python for numerical operations, containing the elements 0, 1, 2, 3. Looking at the actual output, this is indeed correct. This statement claims that the output of unique_labels y is a NumPy array, a specialized data structure in Python for numerical operations, containing the elements 0, 1, 2, 3. Looking at the actual output, this is indeed correct. This statement suggests that the output is a standard Python list. However, the unique_labels function returns a NumPy array, not a list. Therefore, this statement is false. This statement suggests that the output is a standard Python list. However, the unique_labels function returns a NumPy array, not a list. Therefore, this statement is false. This statement highlights the order of elements in the output array. The _unique_labels function maintains the order in which unique labels first appear in the input array y as 0 appeared first, then 1, then 2, and finally 3. This statement is true. This statement highlights the order of elements in the output array. The _unique_labels function maintains the order in which unique labels first appear in the input array y as 0 appeared first, then 1, then 2, and finally 3. This statement is true. This statement asserts that the output will always be sorted numerically, regardless of the input order. This is false. The _unique_labels function preserves the order of first appearance from the input, not a strict numerical sort. This statement asserts that the output will always be sorted numerically, regardless of the input order. This is false. The _unique_labels function preserves the order of first appearance from the input, not a strict numerical sort. This line presents the input data, a list named y, which represents the target variable in a machine learning classification problem. It contains 10 data points, each representing a class label. The labels are integers from 0 to 3, indicating different categories. Understanding this input is crucial because the _unique_labels function will process this specific list to find unique classes. Let's see what's unique in here. This line shows the result of applying the _unique_labels function to the input list y. The output is another list, but this one contains only the unique class labels present in the original list. As we see, it's 0, 1, 2, 3, showing the presence of 4 unique classes in Y. Neat, isn't it? Statement claims that the output of _unique_labels, Y, is a numpy array containing the elements 0, 1, 2, 3. This statement is checked against the actual output. Let's look at the output again and compare. Statement B asserts that the output is a standard Python list. This statement must also be checked against the actual output. We need to ascertain if the data structure is correctly identified. Statement C focuses on the order of elements in the output. It posits that the order reflects the first occurrence of each unique class label in the input list y. This is interesting. Let's examine it carefully. The order must match the order in which each unique element is found in y. Statement D proposes that the output is always sorted in ascending order, regardless of the input order. This statement is crucial because it tests the understanding of whether the function sorts or maintains the order of appearance. Think about what would happen if you scrambled the order of y. This refers to a function within the scikit-learn library in Python. It's used to find all the unique values in a dataset, specifically the labels used in a classification problem. Think of it like finding all the different colors in a box of crayons, ignoring how many of each color there are. This is the input data for the _unique_labels function. It's a list of numbers representing the class labels. For example, in a flower classification problem, these numbers could represent different types of flowers. The function is going to look at these numbers and identify which unique numbers are present. This is the result of applying the _unique_labels function to the input list. It shows us that the only unique values in the input list y are 0, 1, 2, and 3. It's important to note the order. The numbers appear in the order they were first encountered in the original input. This sets up a multiple-choice question. We are asked to evaluate the veracity of several statements about the _unique_labels function output based on the input data provided. It tests our understanding of how this function works. This statement claims that the output is a numpy array, a specific data structure in Python, and that it contains the numbers 0, 1, 2, and 3. We need to determine if this is true based on how the function operates. This statement suggests that the output of the function is a standard Python list, not a numpy array, and that it holds the numbers 0, 1, 2, and 3. This is a key distinction that will need checking. This statement implies that the order of elements in the output reflects the order in which these unique numbers initially appeared in the input list (y). We'll examine if this matches the behavior. This claim states that regardless of the input order, the output will always be numerically sorted from smallest to largest. This is a crucial point to verify given the earlier statements. This line provides the input array, y, which contains the class labels for a classification problem. We'll use this array as input to the uniquelabels function from scikit-learn. This line shows the function call. The uniquelabels function will take the array y and identify the unique values, labels, within it. We are interested in understanding the nature of the output of this function. This is the output of the function. It tells us that the unique labels in array y are 0, 1, 2, and 3. Now let's see how this output helps us evaluate statements A, B, C, and D. This statement checks the data type of the output. Is it a numpy array? Let's check if the output 0, 1, 2, 3 is indeed a numpy array. This confirms that statement A is true. The output of uniquelabels is indeed a numpy array. This statement checks if the output is a Python list. Uniquelabels actually returns a numpy array, not a list. This helps us evaluate statement B. Therefore, statement B is false. The output is a numpy array, not a list. This statement focuses on the order of the unique labels in the output. Does the order reflect the first occurrence of each label in the input array y? Yes. The output 0, 1, 2, 3 reflects the order of first appearance of each unique label in y. Therefore, statement C is true. This statement asks whether the output is always sorted in ascending order. Let's check whether this statement is always true. No, the output is ordered based on the first appearance of each unique label, not by numerical order. Therefore, statement D is false. It's important to remember that the function maintains the original order of appearance of the unique labels. This line presents the input data, an array y representing the target variable in a machine learning classification problem. It shows the class labels for each data point. The labels are integers, 0, 1, 2, and 3. This array will be the input to the unique_labels function. We'll see how the function processes these labels. This line states that the function unique_labels when applied to the input array y produces a numpy array as output. This array contains the unique class labels from y 0, 1, 2, and 3. This is important because it tells us about the data structure of the function's result. This option checks if the output is a numpy array containing the unique labels 0, 1, 2, 3. Based on the output in line 7, this statement is true. The output is indeed a numpy array containing exactly those elements. This option checks if the output is a Python list, not a numpy array. Since line 7 shows the output is a numpy array, this statement is false. Remember the difference between a numpy array and a list in Python, VMC. Numpy arrays are more efficient for numerical computation. This option verifies if the order of the unique labels in the output array follows the first occurrence of those labels in the input y. Let's trace it. 0 appears first, then 1, then 2, and finally 3. The output in line 7 matches this order. Therefore, this statement is true.